In the grand chronicle of cosmic events, our human story is but a fleeting verse. We have witnessed empires rise from dust and return to it. We have charted the stars and split the atom. Yet we remain profoundly fragile beings on a small, blue marble adrift in an ocean of silent, indifferent power. We often ponder the grand threats, the rogue asteroid, the dying sun, the supernova in a neighboring celestial street. But sometimes, the most profound questions of existence and annihilation are hidden within the most mundane of objects. Consider a simple sewing needle, a sliver of steel, perhaps a gram in mass, 2 inches in length, an object of domesticity, of creation, of mending. Now, imagine that needle, that humble tool, is given a velocity that defies the very fabric of our universe. Imagine it striking the earth at the speed of light. Before we chart the course of this apocalyptic messenger, we must first bow to the laws of physics, the unwritten constitution of our reality. One of its most fundamental articles, penned by Albert Einstein in the early 20th century, dictates that no object with mass can ever reach the speed of light. It is a universal speed limit, an absolute horizon. As an object accelerates, its kinetic energy increases. But as it approaches light speed, something strange happens. Time for the object slows down, and its effective mass, its resistance to further acceleration, grows. The energy required to push it faster and faster does not simply increase. It skyrockets, approaching infinity as the object nears that ultimate velocity. To accelerate even a single gram of matter to the speed of light would require an infinite amount of energy, more than exists in the entire observable universe. It is a physical impossibility. The universe, it seems, has built-in safeguards against such absolute violations. But the spirit of inquiry, like the needle in our scenario, is relentless. If we cannot reach the absolute, we can approach it. Let us rephrase our question in a way that respects the laws of reality, yet still grasps for the sublime horror of the concept. What if our needle, our 1-gram harbinger, strikes the earth at 99,999,999,999,999% of the speed of light? This is a speed so agonizingly close to the absolute limit that for all intents and purposes, the consequences are indistinguishable from the impossible fantasy. At this velocity, the mathematics of relativity transforms our simple needle into a weapon of unimaginable power. To understand the energy it carries, we must move beyond the classical world of Isaac Newton, where energy was a simple matter of mass and velocity squared. We enter the realm of Einstein's special relativity, where the kinetic energy is dictated by the Lorentz factor measure of how severely spacetime is warped by extreme speed. For our needle, this factor is a colossal number, in the realm of 70 million. Multiplying this by the needle's rust mass and the speed of light squared, we arrive at an energy figure that is difficult for the human mind to process. The kinetic energy of this single, tiny needle would be approximately 4.3 x 1016 joules. This is a number that means nothing without context. So let us travel back in time, to the dawn of the nuclear age. On July 16, 1945, in the desert of New Mexico, humanity first unleashed the power of the atom with the Trinity test. The bomb, nicknamed the Gadget, released an energy equivalent to about 22,000 tons of TNT. The atomic bomb that devastated Hiroshima was of a similar yield. Our needle, upon impact, would release the energy of not one, but roughly 10 million Hiroshima bombs detonating at the exact same point at the exact same instant. Let us scale up our comparison. The Tsar Bomba, the most powerful nuclear weapon ever created and detonated by the Soviet Union in 1961, exploded with the force of 50 megatons of TNT. It was a demonstration of power so terrifying it shocked even its creators into pursuing test ban treaties. Our 1-gram needle carries the energy of 2,000 tsar bombas. In fact, the total energy of our needle is comparable to, and likely exceeds, the total energy released by the Chicxulub impactor, the 6-mile-wide asteroid that struck the Yucatan Peninsula 66 million years ago, ending the age of the dinosaurs and wiping out 75% of all life on Earth. A 1-gram needle, delivering the same planetary verdict as a mountain-sized rock. Now, let us follow its final journey. The approach would be utterly silent and invisible. It is not a flaming meteor streaking across the sky. It is a relativistic projectile, a ghost of pure momentum. The first sign of its arrival would not be seen, but felt. As it pierces the upper atmosphere, the very air molecules in its path would not be pushed aside. They would be annihilated. The needle would slam into the nitrogen and oxygen atoms with such stupendous energy that their constituent protons and neutrons would be shattered, initiating a cascade of nuclear reactions. A perfect cylindrical channel of incandescent plasma would form through the atmosphere, hotter than the core of the sun. This channel would be a colossal particle accelerator, spewing a blinding, lethal cone of gamma rays, X-rays, and other high-energy particles ahead of the needle. Anyone and anything on the side of the planet facing the impact would be irradiated with a dose of radiation so immense that life would cease in microseconds. This is not burning, this is erasure at a subatomic level. Milliseconds later, the needle itself would strike the Earth's surface. Let us say it strikes the middle of a continent. The concept of a hit is almost misleading. It is not a collision in the way a bullet strikes a target. It is an act of pure energy conversion. The needle and an enormous volume of the Earth's crust, many cubic kilometers of rock, soil, and water would not be displaced. They would be vaporized, not melted, but turned directly into an expanding fireball of elementary particles and superheated gas. The energy release would be so focused and so instantaneous that it would create an explosion that dwarfs any volcanic eruption in geological history. The immediate effect would be a flash of light that would blind any observer on the moon, a flash that would scorch the surface of the planet facing it. This is the new dawn, a false sun that brings only death. Simultaneously, the impact would generate a seismic wave of incomprehensible magnitude. This is not an earthquake we would measure on the Richter scale. The scale itself would be meaningless. This shockwave would propagate through the planet's core and out the other side, ringing the entire globe like a struck bell. Every fault line on the planet, from the San Andreas to the Great Rift Valley, would rupture at once. The planet would be racked by global earthquakes of a magnitude that would liquefy solid ground. Every volcano on Earth would be triggered into a cataclysmic, simultaneous eruption, spewing ash and magma into an already traumatized atmosphere. Back at ground zero, a crater would form, but it would be unlike any crater we have ever seen. It would be a vast, seething bowl of molten rock, dozens of kilometers across and deep, the planet's mantle exposed to the sky. But the more devastating effect would be the ejecta. Billions of tons of vaporized and molten rock would be blasted high above the atmosphere, into low Earth orbit. As this material spread around the globe and began to fall back down, friction would heat each tiny droplet of rock into a miniature meteor. The sky worldwide would light up not with stars, but with a rain of fire. The entire atmosphere would become a planetary-scale convection oven, raising surface temperatures high enough to boil the upper layers of the oceans and ignite global firestorms that would consume everything that could possibly burn. In the hours and days that followed, the world would be a vision from a primeval hell. The oceans would be in turmoil, with hyper-tsunamis hundreds of meters high scouring the coastlines clean. The atmosphere, choked with soot from the firestorms and dust from the impact, would become opaque. Sunlight would be completely blocked, plunging the Earth into a profound and lasting darkness, an impact winter that would make the one that killed the dinosaurs seem like a mild autumn. Temperatures would plummet to far below freezing, And this cold would last for years, perhaps decades. What little life might have survived the initial blast, the radiation, the earthquakes, and the firestorms, perhaps some extremophiles deep underground or in the abyssal plains of the ocean would now face a new challenge. The sky would be gone. The sun, the source of all energy for life as we know it, would be a forgotten memory. The atmosphere itself would be fundamentally altered, poisoned with sulfur compounds and nitrogen oxides from the vaporized rock and air, creating acid rain so corrosive it would dissolve stone. Photosynthesis would cease globally. The food chain would collapse from its very foundation. The oceans would become acidic, dissolving the shells of any surviving marine organisms. In essence, the impact of our 1-gram needle would not just cause an extinction event, it would be a sterilization event. It would reset the planetary clock, forcing Earth back to a state resembling its earliest, most violent history, leaving behind a scarred, boiling, frozen, and poisoned world, waiting for millennia for life to perhaps, just perhaps, begin its slow, arduous climb once more from the primordials, and so we are left with the ghost of a tiny needle, an object so small we might lose it in a carpet, yet capable of carrying the power to unmake a world. It is a profound and humbling thought experiment. It reminds us that the universe is not governed by our sense of scale. Immense power is not solely the domain of giant stars and vast galaxies. It is locked away in the fundamental relationship between matter, energy, and the speed of light, as described in an equation of beautiful, terrifying simplicity, equals mc. This single insight, born from a mind contemplating the nature of light while working in a patent office, revealed that every speck of dust, every drop of water, every cell in our bodies contains a latent energy that defies imagination. Our hypothetical needle is a monument to this truth. It is a story not just of physics, but of perspective. It forces us to look at the familiar world and see the cosmic potential hidden within. The history of human thought is a journey toward understanding these hidden potentials. From learning to control fire to splitting the atom, we have, in our own limited way, learned to unleash a tiny fraction of this power, and we have seen its terrible consequences in the mushroom clouds that haunted the 20th century. The story of the relativistic needle is a cautionary tale written on a planetary scale. It tells us that power and consequence are linked by immutable laws, and that in the vast, silent theater of the cosmos, even the smallest of actors can bring down the final curtain.